Kind of forgive the mess up there, but properties of tangents. Are those page numbers accurate? 5?
Yes.
Okay. There we go. Go ahead and spend some time working on that. Say about 5-10 minutes. All right. Well, let's talk about some of these here. All right. To define, using a picture, there's a picture of a circle and a line that's tangent to that circle. Okay? The point of tangency is where it hits that circle. A line that's tangent to a circle hits the circle in one spot. So from outside the circle, this line intersects the circle right there. It intersects always at a right angle. So line AB is tangent to circle O. Okay? That's called your point of tangency, where it intersects. Yep.
Is this the same tangent that we were using before?
Yep, that's what a tangent is. Yeah. So when you're talking about your trig functions, next year we'll actually show where those are all located on the unit circle. But yeah, same idea. All right. How many made it that far? Okay. Use a picture to summarize theorem 12-2. A tangent intersects a radius at a right angle, and line AB is perpendicular to OP. So that's what that theorem talks about. It talks about how those intersect at that right angle. How does this theorem relate to 12-3? It's just the converse of 12-2. 12-2 and 12-3 are converses of each other. Okay? So just a bit of background knowledge before we start trying some of these. Okay, define, use a picture, circumscribed about, and inscribed in. Okay? If you have a triangle that is circumscribed about the circle, okay, then that means the triangle is inside the circle. It's actually touching all points inside the circle. So you'd have to actually have a circle and a triangle hitting all three vertices on the outer edge of the circle. Okay. Versus a triangle that's inscribed in, or excuse me, a circle that's inscribed in. In this case, the circle is inscribed in the triangle. Okay, it's inside the triangle. Okay, so just some words that you may see today. And the last one, our theorem to summarize 12-4. Here, triangle A, or excuse me, you have circle O with points of tangency at A and C. If you have two tangents coming from the same point outside a circle hitting the same circle, then those tangents are congruent. Okay, so from the point to the point of tangency will be congruent on each of those segments. So AB is congruent to CB. Okay. So that's just a bit of background knowledge. The rest you kind of already have. Okay, we're going to use the Pythagorean theorem a lot today. You may use some foiling today and that kind of stuff, but let's try to apply that. Any questions there? Okay, moving on here. I want you to take a look at your assignment. You can copy some of these problems down in your notes. Okay, but here's number 1. I'll work through there. It says in example 1, in each diagram, TP is tangent to circle C. At point or at P, find the value of X. So we're going to try number 1 and 4 together. We'll work through those two.
I'm going to write those down here.
Yeah, it'd probably be a good idea to put them in your notes and show the work there. That way you have them when you're studying at the end of the chapter. Remember, a lot of this stuff you want to get onto your note card as well. Anytime we have new stuff that you're not familiar with, at some point copy it onto your note card. You have a quiz this Friday that you can use that note card on. Okay? Okay, number 1. Let's see how we did. All right, we got our triangle here. This is a right triangle. Remember, that intersects at a right angle. So we know that this side squared plus this side squared equals that side squared, right? So x squared plus 4 squared equals x plus 2 squared. Okay, this side has a length of x plus 2. Now some of us have struggled with this year a bit. That's x squared plus 16 equals x plus 2 quantity squared means this. And remember you got to FOIL there. So for those of you that just said that's x squared plus 4, that's the common mistake. Okay? Some of you use distributive property, some use FOIL, but whatever you use, you should end up with x squared, and then x times 2 is 2x, 2 times x is 2x, and that's 4. I stack them like that and put the like terms next to each other, so it gives me x squared plus 4x plus 4 equals x squared plus 16. Now you have quadratics that you're dealing with on both sides, which is nice because when you subtract, the quadratics disappear. You collect your x's on the same side. If I take away x squared from both sides, those cancel. I'm left with 16 equals 4x plus 4. Subtract 4 on both sides. 4x equals 12. So 1x equals 3. Now, some of you could have figured that out without even doing that part. Right? If you think of this as a 4, maybe you go, well, that's 4, that might be 3, so this could be 5. Hey, yeah, that works. This has to be the same as that, so it's a 3, 4, 5 triangle. Okay? Maybe you guessed that. Anyone guess that?
She did.
Okay.
Ryan did.
All right.
Ryan did.
Allie did.
I think Ryan did. Okay. Number 4, let's check that one here. What's this length right here?
5.
There wasn't the resounding 5 that I wanted. Okay, but that is 5. It's the same as this. Okay? And so, those of you who know your Pythagorean triples, you might know that one already. Okay? Huh?
Wasn't the theorem?
Oh, hold on. No, that wouldn't be a Pythagorean triple. I'm sorry.
Wasn't the theorem saying like if it goes out to one point, then the two are equal? What?
They're right angle. If they that's if the tangent. So this isn't a tangent. This is secant.
Oh.
Okay? Which we haven't got to with you guys. This is 9. I'm sorry, that's not a Pythagorean triple. I don't know what I was thinking there. So 5 squared is 25 plus x squared equals 9 squared, which is 81. X squared, subtract 25 on each side, is equal to? Equal to what? 56? Okay. And take the root. X is equal to root 56. Now remember, you do plus minus, but the minus doesn't matter because it's an actual length. Okay. So in this case, root 56, we've got to simplify. If they don't tell you to round, make sure you simplify your root.
2 root 14.
Good. So that's root 4 by root 14, or 2 root 14.
I'm a little lost.
Who's way lost? I thought so. You?
I'm fine. I sort of get it.
Sorta?
Yeah.
I sort of.
More
Question
than
on it?
yesterday.
Okay. More than yesterday? Uh-oh.
I'm feeling better.
Hey guys, seriously though, if you have questions, make sure you ask. Okay, a skill that you really need to get in the habit of doing, that you've kind of get the habit out of this year, is if you're going to be in trig next year, which everyone in here is slated to go to trig right now. If you don't get something on your assignment, you can't wait till class that day to come in and ask for help. You really need to try to get in before school or at lunch. Okay, or ask during class the day of the assignment. I know that doesn't always work, but the best you can. For those that go, well, dude, that's my lunchtime, man. Like, I have better things to do with my lunch. That's like my lunchtime. Well, you're right. It is your lunchtime. It's also your assignment. So, in your grade. So, you want to get help. That's why I eat lunch in here. So I can help you. I mean, the company is amazing, but, I'm here to help. All right? So, try to come in. It's really important. especially for next year. But questions on that? Any part? How many think you get it? Okay. All right. How you doing over there, Trevor?
Good.
Yeah?
Yep.
Do you get it?
Yep.
Do you know how I know that? When I ask questions like, how many get it? They raise their hand, or like rate yourself 1 to 5, you actually put your hand up and you don't stare at JJ or whatever you guys were doing. Okay. Example 2. Let's move on to number 7. In each diagram, AB is tangent to circles C and D. Find the value of X. All right. I want you to give that a shot there. Talk about it. Here's the, I'm going to give you the way that I see a lot of times students do this, and then I'm going to show you the correct way. A lot of times I see this line being drawn in, or a diagonal line, either that one or that one, which does not work, because it does not give you a right angle. Okay? It might give you a right angle, but it doesn't always give you a right angle. Okay? It could give, well, I'm sorry, you've got this right angle, or you've got that right angle. However, it doesn't give you something that you can solve for in terms of this triangle, right? Like if you go that route, you can't use this triangle because you don't have a right angle in that one, and you need that side. I mean, you could deal with this, and you could find this hypotenuse, but then you're going to have to use some other way to find x. Versus, if you go and draw an altitude like that, so think of this. It's a little easier. Let me get a straight edge so it's easier to see. Okay? If you draw an altitude,
You could have just said that before we started.
I could have, but then you would have just said, oh, okay, and then, okay. So there. Now, what type of shape is this?
A triangle.
Rectangle.
Oh, wait.
Rectangle. Right angle, right angle. That's for sure a right angle. Okay? This is 6.
I was looking at
This length is 6, and this length is 2. Okay, so now we know this is 2, that's x. What's this?
20.
Yeah, it's a rectangle. It's the same as that, so it's 20. So if I deal with just that little triangle in there,
X equals 2, 1, 1. Get 2 root 101. Yes.
No.
that's the triangle I'm dealing with. Okay, so a squared, 2 squared plus 20 squared equals x squared.
Oh, there's your angle.
4 plus 20 squared is 400.
Plus 4.
It's x squared, so 404 equals x squared. So x equals root 404,
I'm on stuck with this.
which is root 4 by root 101, which is 2, root 101. Okay, you guys see how I kept writing x there? X, x, x. If you're putting the same thing each time, well, here I could have done that. I could have just put the equal sign, or right here. Until you actually change that other side, you can just keep putting the equals. You're bringing the same thing down. Okay? Save you a little time. But as soon as that side changes, you better change it. Okay? Any questions there?
No.
Okay, before we do example 3, I'm going to let you work on example 1 and 2 for about 10 minutes. Okay? So it sounds like number 5 is quadratic. You get a quadratic. Do you get this quadratic?
No.
No, darn, dude. It would make it so much better if it was that quadratic.
So would.
Okay, here's how you factor. You could always try factoring. You can always try completing quadratic formula. Quadratic formula works every time.
Oh, that's easy.
Factoring is the one that will save you a lot of time in the long run. And I'll tell you that this one factors. The way you know you're supposed to use the quadratic formula or factoring is anytime you're solving a quadratic. Here you're trying to solve for x and you have an x squared and an x. You have an x squared and an x, that's quadratic. You use one of those two methods. You could always use completing the square or graphing if you know how to do those two. Okay, so in this case right here, if I'm doing factoring, I'm multiplying a by c. In this case, a is 1. Remember your terms, that's a. That's B. And this is C. Review of algebra real quick. Okay? I'm going A times C. Two things that multiply to make that are 1 times negative 12. So negative 12. And here I'm putting my B term. My B term is 4. So I need two things that multiply to make negative 12 and add to 4. Do all the factors of 12. 1 times 12, they won't add to 4. 2 times 6, well 2 and 6, you can make a 4. Okay, since this is negative, one of those two things has to be negative. 2 times 6, next. Negative 2, positive 6. Negative 2 times positive 6 makes negative 12, and it adds to 4. So my factored version is x minus 2 times x plus 6 equals 0. Using zero product property, noting that anytime I multiply two things together to get 0, one of those two things has to be 0. X minus 2, if that equals 0, then x would equal 2. And this one, x plus 6, if that part equaled 0, x would have to be negative 6. If I'm solving for a length, which one of these could not work?
Negative 6.
Negative 6. That's extraneous. This would be my length. Now, if I'm using the quadratic formula,
Yeah, can't you just use
quadratic formula, you could just use that. You need to know how to factor for next year. But the quadratic formula, x equals the opposite of b plus or minus square root of b squared minus 4ac all over 2, eh?
Yeah.
We have our a, b, and c right here. Has to equal 0 to get that a, b, c. So opposite of b is 4 plus minus square root of b squared. Make sure you're substituting in parentheses. Those that don't do that and don't get in that habit now, I'll be shaking my head saying I told you so when you make the mistake later. I'll give you a smile though and pat you on the back and say, you know what? Everyone makes that mistake. Substitute using parentheses. Okay? A is 1, C is negative 12. Some people that don't use parentheses, they'll end up subtracting 12 right there. Okay, they'll forget the negative. 2 times 1. Alright? So I get negative 4 plus minus 16, square root of 16 minus 4 times 12 times negative, or 4 times 1 times negative 12. Notice I circled that. That's a negative times a positive times a negative, which is a positive 48. 48 there, all over 2, which gives me negative 4 plus minus 16 and 48 is
No. 60. I was off by-
64 over 2,
Yeah, it's-
which that part there is 8, so it's negative 4 plus minus 8 over 2. From that point, you break into two different problems. You got negative 4 plus 8 over 2,
Negative 4.
and negative 4 minus 8 over 2.
4.
Just 4 over 2, or 2. Negative 12 over 2, or negative 6.
Which is what you got in the previous.
Yeah, same problem, so should get that. Remember, length can't be negative, so that one's extraneous. That's our answer. Okay, now with that being said, you won't have tons like that this year, but you have to be an expert at doing this next year. We talked about that last week, right? Some of you are gone. You're like, I don't even know if you know I'm up here. Okay? Some of you are like, whoa, that's like math. I know. You're a sophomore in this class. It's a sophomore level class. Next year's junior level. Yeah, crazy, right? And then your freshman year, for those of you that are in, or your 10th grade years, for those of you that are in 8th grade this year, your 10th grade year, you'll be doing senior level, which you get college credit for you. Okay? You guys, the others, you guys that are freshmen, you'll be doing it your junior year, which you get college credit for. Okay? So you're getting close to college level math. So it gets tough, man. But you can do it. Nick?
What's the class after your trig called?
Pre-calculus. Math analysis at our high school.
Is that the calculus?
Stats or more math if you want. Alright, here we go. Example 3. It depends where you want to go. You kind of start setting things in greater detail at that point. Okay, I want to look at example 3 real quick. In each diagram, a polygon circumscribes a circle, meaning it goes around the circle. Find the perimeter of each polygon. Now remember that from a tangent, or a tangent that hits a circle, and another tangent from that same point that hits the same circle, what do we know about these lengths?
They're equal.
They're equal. So if this is 13, this is 13. What's this?
8.
That's 8. What's this?
12.
12. Now I found all those links because it says find the perimeter. Now I just add them all up.
Yeah, 13.
25. You guys are all calculator, right? You don't want to get 25 plus 20, 45.
Yep.
Why even challenge ourselves?
I don't know.
66. 66. We'll just go 6. Use my calculator. 66. Whatever. I challenge you to use your brain.
We're using our resources.
I challenge you to use your mental math abilities.
If we buy it and we spend our hard to make it earn money and we just wasted it, we gotta say.
I know, but it's faster. Either way, it's less buttons to push.
This is more accurate.
What is this one?
That is 14,
7, 10,
28, 18,
28.
Good.
okay,
You
28.
shouldn't have brought us these cards.
I was getting there, guys.
You could just go 6, 8, and 14. I mean, you could 10, 10, and 8.
Let's go tap.
Good job. All right. Hey, go ahead and finish up that side. In about 5 minutes, we're going to correct yesterday's.